Now, in this lecture, we will find the values of x and y. In the drawing, we have a shape. The area of this shape equals to 240 units square. The width of the shape is 15 units, and the length of this shape equals to 20 units. And we want to find out the value of x and y. First of all, we will give names to the vertices of this shape. We will name this vertex as A. We will name this vertex as L. Then we will name this vertex as C. And we will also name this vertex as D. Okay. In the next step, we will lengthen segment X to a size of 20 units, like the size of CD. We will lengthen segment X to 20 units, so we will extend segment X to 20 units, like the size of CD, and then we will lower perpendicular from the line that we drew to segment CD. Again, we lowered perpendicular to segment CD from the line that we drew, and we will name the new vertex here as F. Okay, actually this angle is 90 degrees, and this angle also equals to 90 degrees. Angle CDF equals to 90 degrees, and angle LFD also equals to 90 degrees. Actually, we built a rectangle because side AF equals to side CD, and they are parallel to each other, and also side AC of this shape equals to side FD. Both of them equals to 15 units, and also FD is parallel to AC. For this reason, the shape AFCD is a rectangle. Okay, so the shape of AFCD is actually a rectangle. Okay, AFCD is a rectangle, so we actually built from the shape that was given to us, we built a rectangle by lengthening or extending segment X to 20 units, and then we lowered perpendicular from point F to segment CD, and in this way we created rectangle AFCD is a rectangle. And actually the area of any rectangle is equals to the length of the rectangle times the width of the rectangle. Okay, the area of any rectangle equals to the length of the rectangle times the width of the rectangle. Okay, again, the formula for the area of any rectangle equals to the length of the rectangle times the width of the rectangle. So we can calculate the area of this rectangle because we know that the length of this rectangle is 20 units and the width of this rectangle is 15 units. So the area of rectangle AFCD equals to 20 times 15 equals to 300 square units. Okay, the area of rectangle AFCD equals to 300 square units. But we also know that the area of the right shape equals to 240 units squared. So actually the area of the right triangle LFD, the area of the right green triangle, the area of the right green triangle will be equal to the area of the rectangle minus the area of the white shape. Okay, so I write it down. The area of triangle, right triangle LFD equals to the area of the rectangle minus the area of the shape that is given to us, that equals to 240 units squared. Okay, the area of the shape ALCD equals to 240 units squared. Again, the area of the right triangle LFD, of the green right triangle, equals to the area of the rectangle minus the area of the shape that is given to us. Okay, the area of ALCD. So the area of the rectangle minus the area of the shape that was given to us equals to the area of the right triangle LFD. Okay, so we know that the area of the rectangle equals to 300 units squared. The area of the rectangle equals to 300 units squared, and the area of this shape is given to us, and it equals to 240 units squared. So 300 minus 240 equals to 60 units squared. So actually the area of the green right triangle equals to 60 units squared. Okay, so I will draw again the right green triangle LFD. we know that the area of the right green triangle equals to 60 units squared. The size of side LF of the green right triangle equals to 20 units minus x. Okay, the area of the size of side LF of the green right triangle equals to 20 units minus x. Okay, and we know that the area of the right green triangle equals to 60 units squared. Okay, so I do again the right triangle LFD. Side DF of the right triangle equals to 15 units. Side LF equals to 20 minus x units, and the area of the green right triangle LFD equals to 60 units squared. So we actually can use the formula for the area of a triangle in order to find out the value of x. Actually, the formula for an area of a triangle equals to the base of the triangle times the height to the base over 2. I will repeat again. The area of the formula for the area of any triangle in the world equals to the base of the triangle times the height to the base over 2. You should remember that the height to the base must create 90 degrees with the base. Okay, so we can calculate the area of the right triangle LFD according to the formula of the area of the triangle. So our second equation will be the area of the right triangle LFD, the right green triangle LFD. We know that the area equals to 60 units, so we can write down that 60 units equals 60 units square equals to the base of the triangle. The base of the right triangle, right green triangle, equals to 20 units, 20 minus x, minus times the height to the base. The height is 15 units because of the fact that DF is perpendicular to LF. For that reason, DF is the height to the base of this triangle. So the height is 15 units over 2. So the formula for the area of the triangle, the right triangle, right green triangle is 60 units. We know that the area of this right triangle, right green triangle equals to 60 units, and it equals to the base of the triangle, that is 20 minus x, times the height to the base, that is 15, over 2. Okay, Now we will multiply equation number 2 by 2. So we multiply the equation number 2 by 2. 2 times 60 is 120, and 20 minus 6 times 15 divided by 2 times 2 is 20 minus x times 15. We will open the brackets in this second equation. So we open the brackets in this equation. 20 times 15 is 300, and x times 15 is 15x. Now we'll subtract 120 from equation number 2. So we subtracted 120 from equation number 2. 120 minus 120 equals to 0. And 300 minus 120 equals to 180. So in total we got that 0 equals to 180 minus 15x. Okay? 0 equals to 180 minus 15x. Now we will add 15x to this equation. So we added 15x to the second equation. 0 plus 15x equals to 15x. 180 minus 15x plus 15x equals to 180. We will divide the equation number 2 by 15. We divided the equation number 2 by 15. We got that x equals to 12 units, because 180 over 15 equals to 12 units. So x equals to 12 units. So if x equals to 12 units, x minus 20 minus x is 20 minus 12. It equals to 8 units. So in this right triangle, we have one side that equals to 15 units, the other side equals to 8 units. So we can use the Pythagorean theorem in order to find out the value of y. Okay, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so in this specific right triangle, the square of the hypotenuse is y square equals to the sum of the squares of the perpendiculars equals to 15 square plus 8 square. Okay, here in the third equation we implemented the Pythagorean theorem in the right triangle LFD. We got that y square equals to 15 square plus 8 square. 15 square is 225 and 8 square equals to 64, so I write it down. Okay, y square equals to 15 square is 225 and 8 square is 64. 225 plus 64 is 289, so I write it down. So we got in the third equation that y square equals to 289. Now we will take a root out of equation number 3. We'll get that so the root of 289 is 17, so y equals to 17 units, and we have already found that x equals to 12 units. Okay, x equals to 12 units and y equals to 17 units. So the answer to the question is that x equals to 12 units and y equals to 17 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the values of x and y. We wanted to find out the value of x and y in this shape. We know that the area of this shape equals to 240 units squared, and the width of the shape is 15 units, and the length of this shape is 20 units. And we want to find out the value of x and y. We actually made a construction. We extend line segment X to the size of 20 units, and then we lowered perpendicular from point F to segment CD, and in this way we created a rectangle from the area that was given to us. We created a rectangle by extending segment line X to a size of 20 units, and then we lowered perpendicular from point F to segment CD. So it is actually shape AFCD is a rectangle because of the fact that AF equals to CD and AF also parallel to CD, and FD equals to AC and AFD also parallel to AC. For that reason, shape AFCD is a rectangle. Okay, And we know that the area of any rectangle equals to the formula for the area of any rectangle equals to the length of the rectangle times the width of the rectangle. And we know that this rectangle AFCD, the length of this rectangle is 20 units and the width is 15 units. So the area of rectangle AFCD is 20 times 15, that is to say 300 square units. Okay, we also can see from the drawing that the area of the rectangle minus the area of the white shape equals to the area of the right triangle. Again, the area of the rectangle minus the area of the white shape equals to the area of the green right triangle. Okay, the area of the green right triangle LFD equals to the area of the rectangle minus the area of the shape that was given us, the white shape. Okay, so the area of the rectangle is 300 units squared and the area of the shape that was given to us is 240 units squared. So 300 minus 240 is 16 units squared. So the area of the right triangle, right green triangle equals to 60 units squared. So we draw again the right triangle LFD. We know that the area of this right triangle equals to 16 units squared. This side FD equals to 15 units and this side equals to 20 minus x. We use the area for the formula for the area of the triangle in order to find out the value of x. And the area of any triangle in the world equals to the base of the triangle times the height to the base over 2. So the area of this right triangle will be equal to the base of the triangle, that is 20 minus x, times the height to the base, that is 15 units. You should remember that the height must create 90 degrees with the base, and FD, that is the height, creates 90 units with the base because FD is perpendicular to LF. So FD is the height of this right triangle. So the formula for the area is 20 minus x times 15 over 2 and it equals to 60 units. Okay? 60 units equals to 20 minus x times 15 over 2. We multiplied the equation number 2 by 2. We got that 60 times 2 equals to 180 and all equals to 20 minus x times 15, because 20 minus x times 15 divided by 2 times 2 equals to 20 minus x times 15. We open the brackets, the second equation. 20 times 15 is 300 and x times 15 is 15x. So we got that 180 equals to 300 minus 15x. We subtracted 120 from equation number 2. We got that 0 equals to 180 minus 15x, because actually 120 minus 120 equals to 0, and 300 minus 120 equals to 180. So in total we got here that 0 equals to 180 minus 15x. We added 15x to the second equation and we got that 15x equals to 180. We divided equation number 2 by 15. We got that x equals to 12 units. Okay, so after we know that x equals to 12 units, then we know that side LF of this right triangle equals to 20 minus 12, that is 8 units. So we know that side LF equals to 8 units, side FD equals to 15 units, and the only missing thing is the hypotenuse of this right triangle. We can use the Pythagorean theorem in order to find out the value of the hypotenuse. And the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, y square equals to 15 square plus 8 square. Okay? 15 square is 225, 8 square is 64. So we got that y square equals to 289. We take a root for equation number 3. And we got that y equals to 17 units and x equals to 12 units. Okay, so the answer to the question is that x equals to 12 units and y equals to 17 units. Okay, thank you very much.